Hello. Uh, Today we're going to revise on mass. Okay, going to revise on mass. Now, what are the equations that is related to mass? Of course, the most commonly asked question about mass is what is the weight of a certain mass. So weight equal to mass times gravitational free fall acceleration. Example, if I have an apple, okay, now the planet Earth will attract the apple with a certain gravitational attraction force that we call weight. Now if this apple is 200 gram, say if this apple is 200 gram, then when we apply this equation to find the weight, remember that the mass must be in kilogram. 1 kilogram is 1000 gram. So 200 gram divided by 1000 will be 0.2 kilogram times, on the surface of our planet Earth, for O level we take it as 10, and that will be 2 Newton. That means the planet Earth attracts near the surface of the planet Earth, attracts the apple with a force of 2 Newton, and we call this gravitational attraction force the weight. Now next, for mass, we have the gravitational potential energy, which is mgh. Now suppose if the apple is 3 meter above the ground, now how much potential energy due to gravitational attraction does the apple have? We say that is mgh, which is 0.2 kilogram. Suppose it's the same apple, times g, which is 10, times 3 meter, and that will be 6 joules. Okay, 6 joules. Now any other equation that is related to mass? Yes, of course, kinetic energy, which is half mv squared. Suppose if I throw the apple at a speed of 3 meter per second. Now this apple, due to its movement, will possess energy, and we call this the kinetic energy, which is half mass times speed squared, which is half times 0.2 kilogram times 3 meter per second squared, and that will be 0.9 joules. This is the amount of energy that the apple has. Now of course there is other equation that is related to mass, which is of course density equals to mass over volume. Now in all the cases, the mass must be in kilogram. The mass in mgh must be in kilogram. The mass in half mv squared must be in kilogram. Now in density, it may be in kilogram or gram. Example, 4 gram per cm cube. Okay, example, 6 kilogram per meter cube. So for calculation of density, it may be in gram or kilogram. So for all other calculation, mass will be in kilogram, except for density, it may be in gram or kilogram. Now there is one more important equation that relates to mass, which is resultant force equal to ma. Now if I have a box, somebody push the box with 8 Newton and the friction is 3 Newton, we say that the resultant force is 8 minus 3 because opposite in direction, which is 5 Newton. Now if the box is say 200 gram, then there'll be 0.2 kilogram times A, and therefore the box will move to the right, of course, with 5 divided by 0.2, which is 25 meter per second square. Of course, this example is rather fast, this rather big, the acceleration. So this is also important equation that is very common. Resultant force equal to mass times acceleration, meaning that if the total resultant force add to the right, the box will move to the right with this acceleration. Okay, so this is a mass revision about mass. Okay, a mass revision about mass. Okay, and what's the definition of mass? Is the amount of matter in the body, amount of matter, and this will not change even if you go to other planet. It will not change. Okay, and it's unlike weight, which is a force, it will change depending on which planet you go to. Okay, thank you, good luck for your O level.